Let us understand the crystal field theory, its assumption to explain coordination compounds. I said already in the last video, it was proposed by Hans Bethe in 1929 before valence bond theory. Let us know what that actually crystal field theory is. Since crystal field theory could wisely explain the colors and magnetism, we are studying that theory. This theory is based on pure ionic or electrostatic interaction between central metal ion and surrounding ligands, more correctly ligand field. This theory assumes metal ion is positively charged and there is nothing great, it is true, and ligands as negative point charges. Even if I consider neutral ligand like ammonia, carbon monoxide, water, it considers negative pole out of the dipole which points toward the metal ion. So with reference to metal ion, in terms of metal ion, the approaching species are negatively charged. Though from our point of view, in totality point of view, they are neutral since negative pole out of dipole points towards the metal ion. Crystal field theory assumes ligands, maybe it is a neutral ligand or anionic ligand, those are negatively charged. Those are as negative point charges. The first assumption that already I told to you, crystal field theory assumes ligands as negative point charges. Sometimes ligand itself remain of the size of the central metal ion. Ligands which have donor atoms like sulfur, phosphorus, they are larger in size and their sizes are more or equal to size of the metal ion. To metal ion it is giving good weightage, but for ligand only point charges. Practically it is not true. So this theory suffers to the limitation, but time being we will accept that ligands as negative point charges is a first postulate of crystal field theory. The second postulate is interaction between metal ion and ligand is purely electrostatic or ionic. In true sense, it is not correct because covalent characters are there in the coordination compounds or coordinate bond. And few observations are there which we could not explain unless we consider the covalent characteristics. But what crystal field theory assumes, that we are going to study. So what is assumption? There is a pure ionic interaction between metal ion and ligand. And free state of metal ion is with d orbitals which are degenerate. Degenerate means they are of same energy level. 5 d orbitals are there in d subshell. 5 d orbitals are there and all 5 d orbitals are degenerate in free metal ion. Now third postulate in related to the second one. I said in free metal ion all 5d orbitals are degenerates. They are of the same energy, means dxy, dyj, dxj, dx square minus y square, dz square, all orbitals are of the same energy level. If we consider, it's a imagination. If we consider spherically symmetric hypothetical field, metal ion is at center and around metal ion negative field which is spherical field. In spherically symmetric field means from all directions equal negative field is there because of ligands on metal ion. But practically it is not true. That crystal field theory assumes since various geometries are there, maybe linear geometry, triangular geometry, tetrahedral, trigonal, bipyramidal, octahedral, square planar. Geometries are different, means approach of ligand is not spherically symmetric. Because of absence of spherically symmetric field, d orbitals will experience different interactions. No longer they can remain degenerate. Those d orbitals will split in energy. One orbital will experience strong interaction, other will experience less interaction. So they will split in the energy. Splitting of their energies will take place. That's the assumption of crystal field theory and it's an important assumption. Means if I consider octahedral field, then those 5d orbitals will split in two parts. One triplet, T2G that we say, and other doublet that we say as EG. So splitting of d orbitals in two parts is nothing but the crystal field splitting. It occurs because of octahedral field, because of nature or approach or directions of the ligands, because of absence of spherically symmetric field. Exactly what it is that we are studying in detail. Are these three important postulates clear? Crystal field theory considers ligands as point charges, negative point charges. Even if ligand is neutral, then also. Ligand is larger, then also. And second, it considers which kind of interaction? Purely ionic interaction between metal ion and ligands. And in free metal ion, 5d orbitals are degenerates. What's the third postulate? In hypothetical spherical field, ligands should experience same kind of interaction to metal ion, but in true sense, it is not because of various geometries, and therefore the orbitals will rearrange themselves. Orbitals will be with different energies. Orbitals will split. That is our third postulate. Are these three postulates clear? Now it is a time to learn the shapes or orientations of d orbitals, because unless you know the orientations of d orbitals, how interaction with the ligands is occurring, will not understand. Therefore, let us know what are those d orbitals, how are they aligned or oriented, what are their shapes. See here, the 5 d orbitals are represented. One by one, let us see. dz square orbital. The orbital, the lobe is along z axis. And if you observe, as like a ring is on the Saturn satellite, or the donut is a food atom, or you can say medu vada, their ring kind of the structure remains. Such kind of the ring is there around the z axis or along x and y. So partly it has a orientation towards x and y, and major orientation is towards z axis. Let us consider by yellow color positive wave function and by brown color negative wave function is represented. Wave function is not important at this moment, but orientation, shape is important. What's the understanding of the dz square orbital? dz square orbital is oriented more towards z axis and partly towards x and y. See the second orbital. dx square minus y square. Lobes are along x and y axis, perfectly along axis. So two opposite lobes are with yellow color and other two opposite lobes are with brown color. Are you understanding dx square minus y square orbital? See the third orbital. That's a dyz orbital. The yz plane, if I consider towards you the y axis and upside z axis, then this is the yz plane. The lobes will be in between y and z axis. Two opposite lobes, yellow colored lobes are between y and z. Accordingly, brown color opposite lobes are also between y and z. So lobes are making angle 45 degree to axis, to y axis and z axis. So lobes are in between axes. That's a dyz orbital. See the next orbital, dxz. Here also lobes are in between axes, but axes are x and z. Means x-axis to our left, right, and z-axis upside, the positive x and the positive z. Then in between x and z, there will be the lobe. Similarly here lobe. So what is the angle made by this lobe to the axis? It is 45 degree to x and z axis. So yz orbital is in yz plane. Xz orbital is in xz plane. Likewise now last orbital, xy orbital, it will be in xy plane. X-axis, y-axis. So in between x and y there will be the lobe. Similarly other three lobes will be there. What will be the angle by the lobe to any axis, x-axis or y-axis? It will be 45 degree. What you are finding? Last three orbitals, dxy, dxz, dyz, those are in between axes. And first two orbitals, dx square minus y square and dz square, those are along axis. dz square, majority contribution is along z axis and partly along x and y. dx square minus y square completely along x and y axis. dyz in between y and z, dxz between x and z, dxy between x and y orbitals. That's the understanding of these orbitals. This is very important. If this imagination, if these shapes are clear to you, then next part, interaction and accordingly energetics of various orbitals will be perfectly clear to you. To make this concept clear, with this model I explained to you, so that concept will be more clear. Let us consider the red bonds, z-axis, positive z, negative z direction. Towards your right and left is x-axis, yellow color x-axis. Positive direction, negative direction. Towards your side and my side, y-axis. Positive direction of y and negative direction of y. Let us understand these orbitals again. First orbital is dz square orbital. The lobes are along z-axis, see here. Plus, as like donut, the ring structure is there. That ring structure is in this xy plane. Actually, dxy, dyj, dxz, three kinds of orbitals are there. Three pairs are possible. Likewise, as dx square minus y square is there, there should be dz square minus y square. There should be dz square minus x square. But those are not there. Combination of that dz square minus y square and dz square minus x square is our actually dz square orbital. Other component we are not mentioning, but it is there. So that ring kind of structure is in xy plane. So if I have to understand this orbital is more along z-axis and it is there in xy plane also. Not exactly x and y direction, but in xy plane. Is that dz square orbital clear? Second orbital is dx square minus y square orbital. It is perfectly along x and y axis. So lobes will be along x axis and along y axis. So it is in this xy plane and along x and y axis. Now see the third orbital, dyz orbital. Where is our y axis? Yes, towards you and towards means y. Where is z? Up and down. So in between y and z here, in between, if I rotate that here will be the one lobe of dyz. Opposite lobe will be here. Next lobe, opposite lobe. So likewise, in between y and z, the lobes will be there. So if I cut that yz orbital, the lamina will be in this way. It is a yz plane. Is dyz orbital clear? It is not along y and z axis. It is in between y and z axis. Now see the fourth orbital. That's a dxz orbital. Now it will be very clear. It is x-axis and z-axis. In between x and z, one lobe, opposite lobe, third lobe, last lobe. So in between x and z. So what is the angle made by those orbitals, those lobes to the axis? So to z-axis 45 degree, to x-axis also it will make 45 degree angle. So it is in which plane? It is in xz plane. This plane is perpendicular to previous yz plane. When water molecule we studied at that time, these planes we have studied. Same concept we have to apply here. Now last orbital, that is xy orbital, dxy orbital. It is your x-axis and y-axis. Where will be the lobe? Along x and y? No, in between x and y. So lobe will be between x and y, making 45 degree angle to x-axis or to y-axis. Similarly, opposite lobe, third lobe and last lobe. Likewise, the lobes will be in xy plane. Is this dxy orbital clear? So what crystal field theory considers? Surrounding ligands, whichever are there, as point charges. Second point, there is a electrostatic force of interaction, ionic interaction between point charges, negative point charges, so ligands, and positively charged metal ion. The d orbitals of free metal ions are degenerate. And in spherically symmetric hypothetical field, interaction will be there, negative field of ligand and electrons of the d orbitals. In spherical symmetric hypothetical field, degeneracy is maintained. But in our geometries, here octahedral, in other geometries, tetrahedral, square planar, triangular, trigonal, bipyramidal, any geometry you consider, The interaction will not be uniform as is there in spherical symmetric hypothetical field. Therefore, energy change will occur in the orbitals. If you know the shapes, then energy change you will understand. What are the shapes? dz square orbital along z axis and in xy plane. Dx square minus y square orbital along x and y axis. Dyz orbital in between y and z. Dxz orbital between x and z. Dxy between x and y. That's the understanding. If you are with, then basis of crystal field theory is clear to you. Let us apply this basis of crystal field theory in order to describe the various geometries for coordination number 2 to coordination number 6 from next part. Part of homework, you have to mention angle made by lobes of dxy orbital to x-axis. Just that angle you have to mention in the comment box. I am waiting for your answer.